The symbol g can be used to refer to the acceleration due to gravity. The acceleration due to gravity g has a unit of meters per second squared. G can also have another unit. Which of these is also a unit for g? So gravitational pull is basically the effect of a force on a mass. So the unit of force is newtons and mass is kilograms. So you're looking at newtons per kilogram over here. Next, two students try to determine a value for g, the acceleration due to gravity. They measure the time t for a small steel ball to fall through a height h from rest. They measure t to be 0.74 seconds using a stopwatch. They measure h to be 2.5 meters using a meter ruler. Calculate the value of g from the student's measurements. Use the equation 2h divided by t squared equals g. This is just substitution. It should be very easy, really. Just make sure that if you don't have a scientific calculator or you're not sure how to use one, deal with each part separately. There's no shame in it. So do 0.74 times 0.74 first, because that's time squared. Work that out. And then do 2 times 2.5, which is going to be 5. And then you just do 5 divided by the answer to that, which is 9.13 meters per second squared. Now remember, what they're doing is they're allowing a ball to fall from a height and they're timing it. So they're just using a stop clock and timing this ball's descent. And because of this, they are getting variation in their results. They record the time t for 2 more drops from the same height. The 3 values for the time are this: 0.74, 69, 81. Calculate the average value of time t to an appropriate number of significant figures. Appropriate number of significant figures is important to understand. Appropriate would be the same used in the question. So here they're using 2 significant figures. 0 is not a significant figure. So to work out an average, you add all the values together. None of these are anomalous. They're all fairly close to each other. Not one stands out from the other. If one did, you'd have to discount it. You add all of the valid numbers together. Press equals first on your calculator. Don't immediately divide by the number. So equals would be 2.24. It's really important you do that. Lots of people make a mistake by just adding these together then dividing by 3 without pressing equals first. Then you divide by 3 and you'll get 0.746 reoccurring, which will be 0.75 to 2 significant figures. You know it'll be 0.75 because this number is greater than, well, 5 or above, so that affects this number by making it go up by 1. If it was lower than 5, it would stay as 4. Explain one way the students could improve their procedure to obtain more accurate values of g. Now the biggest issue here is they're using a stop clock and therefore they're relying on human reaction time, which can be very variable. So it might be better to get an electronic timer or a computer activated timer, something like that. So use an electronic timer to avoid errors caused by reaction time. Notice how this is an explain question, so you have to state the difference you'd make and then give a reason for that to avoid errors caused by reaction time. 2 marks. A car travelling at 15 meters per second comes to rest in a distance of 14 meters when the brakes are applied. Calculate the deceleration of the car. Use an equation selected from the list of equations at the end of this paper. So if you go to the end of the paper, look through the list and it should be pretty obvious which one you need to pick. Look at the values you've been given. A car travelling at a velocity of 15 meters per second comes to rest, so that means 0. So there's a change in velocity. You've got your initial velocity and your final velocity, which is 0. In a distance of 14 meters, so you need something which has distance in it. Calculate the deceleration. Deceleration is the same as an acceleration. So we've got change in velocity here, distance, and acceleration, which we need to find out. So it's v squared minus u squared equals 2 times a times x. And what we need to do is we need to rearrange this to get it in terms of acceleration. So firstly, let's deal with this side of the equation, v squared minus u squared. So final velocity is 0 because it comes to rest. That's why I've highlighted it yellow. And the initial velocity is 15 squared. So if you do 0, take away 15 squared, you get minus 225. So a negative, by the way, a negative acceleration is a deceleration. So we're getting negative values already, which means we're doing this right. Next, because everything on this side has been multiplied by 2, to get rid of it on that side, we need to divide both sides by 2. So by dividing both sides by 2, we basically get rid of the 2 on this side, And over here, by dividing it, this is the operation we actually carry out. So minus 225 divided by 2 is minus 112.5. So now we've just got acceleration and distance to worry about. And distance, well, both sides, this side has been multiplied by distance. So to get rid of distance again, we have to divide both sides by distance. So we divide both sides by distance. And by doing that, we cancel out distance on this side. Distance, remember, is 14 meters. So we do minus 112.5 divided by 14 equals, and here's our answer, minus 8 meters per second squared. Now, remember, it's a deceleration, so we're looking for a minus value, and that will get you full marks.